Okay, so complete combustion is actually any time you have carbon and hydrogen molecules with oxygen, or carbon, hydrogen, and oxygen molecules. So I just put letters here because it doesn't matter how many carbon and hydrogens there are, right? So I could have C2H02 or something. It doesn't really matter. What matters is the type of elements that are here. So if you have carbons and hydrogens or carbon, hydrogen, oxygen with oxygen as a reactant, this is called complete combustion. So meaning the products of complete combustion are always the same: carbon dioxide and water. Okay, so carbon dioxide is a gas, but water is usually a liquid. Now, this is the one case where if you're doing a reaction, the water is assumed to be a gas. The reason why is because when this reaction happens, there's lots of heat that is produced at the same time. So the water essentially becomes water vapor. So in general, when you do a combustion reaction with a hydrocarbon or hydrogen, carbon, oxygen, the products of that is always the same: carbon dioxide and water. The only time it is not that is if they indicate that it is something called incomplete combustion. So incomplete combustion is where you have actually 4 products that are made. So let's say we had a CH4 reacting. So this is a gas, methane is a gas, oxygen. So incomplete combustion is where you have carbon dioxide and water produced, but also carbon is produced as a solid plus carbon monoxide gas. So this is dangerous for a couple of reasons. So first of all, this carbon soot is basically like an ash. So if you've ever seen something that's burned, that maybe like a piece of wood or something on a campfire, and there's ash that goes into the air, that's essentially solid carbon that is being produced. Carbon monoxide you may have heard of because your home probably has a carbon monoxide detector. And this is something that is dangerous because essentially it will cause suffocation. Now, when does incomplete combustion happen? This happens if you are doing a combustion reaction without a sufficient amount of oxygen. So maybe you're burning something inside of a room instead of outside. You have less oxygen than you should. So anytime you are doing any sort of combustion, burning, even if you're lighting a candle, you need to have enough oxygen available. So if you're, for example, let's say you have, your fireplace is going, that's the reason why you have to make sure your chimney is open, because all of those, any sort of fumes that are coming off that may be dangerous for you to breathe in, have to be well ventilated. So incomplete combustion happens when there is a lack of oxygen. Okay, but you are going to assume that you are always doing complete combustion. So anytime I say, this is something is combusting, you are assuming it to be complete unless you're told it is incomplete. Okay, obviously if I say, the following reaction is incomplete combustion, that's going to tell you that you have incomplete combustion. But let's say, for example, we did octane. So octane is one of the main components of gasoline, and this is actually a liquid. And let's say we were to do combustion with this. You are going to assume, you always assume complete. Okay, unless you're told otherwise. So what does that mean? The products are the same: carbon dioxide and water. All right, so let's balance this. Let's practice balancing. So we have 8 carbons, 18 hydrogens, which means we need actually a 9 in front of this to get 18. And we have, let's look at our oxygen count, 8 times 2, that's 16. 16 plus 9, what's that, 25? 25 oxygens. Uh-oh, it's an odd number. So hopefully you remember what to do when it's an odd number going in front of oxygen. We need to double everything. So we're going to double. We're going to double and double again. So what that ends up being now is 50 oxygens, which makes us put a 25 in front of O2. So you always assume that you have complete combustion if you have a hydrocarbon or something that has oxygen, carbon, and hydrogens, but you need carbon and hydrogens for that to work.